For those of you with the book, we're going to be talking about, I'm going to be talking about vitamins, minerals, and water. The information is found in Module 1.5 and 1.4, I think. We're looking at the chemistry, functions, and categories of vitamins and minerals, and we'll look at some of the functions, and we'll touch on intake and excretion of water. We'll go over all of this again when we get to Module 5. Vitamins, some are considered essential, which, if you recall, essential means that they are required for the growth, repair, and maintenance of the body, and that if we don't get them, deficiency symptoms will develop that can be reversed when those nutrients are added back into the diet. Vitamins are organic compounds, which means they contain carbon, but also other elements. They are non-caloric. So and if you recall, calories means energy. So when you take that vitamin and you think it's giving you a lot of energy, it's probably the caffeine in your coffee. All vitamins are needed in tiny amounts, microgram or milligram amounts. And that's really tiny when you compare it to the amount of grams that we need for carbohydrates, proteins, and fats. That doesn't mean they're any less important. It just that means that we need less of them in order for our body to function. Let me talk to you about bioavailability. Bioavailability refers to the amount absorbed and used by the body, right? Just because something has twice the amount of magic in it, just because something has twice the amount of vitamin C in it doesn't mean our body can use all that vitamin C. I think this goes back to a question somebody had about superfoods. There are no superfoods. There are different factors that can affect the bioavailability of food. Your health, the efficiency of your digestive tract, right? That's going to affect your ability to absorb and utilize nutrients, your nutritional status, how the food is prepared. Some foods, the nutrients in those foods are more bioavailability. They're more bioavailable if they've been heated. Others, if they are raw. I don't want you to worry about eat the food because you like it. I don't want you to worry about the preparation of it for nutrition reasons. If you are looking at this video right now, there's a good chance that you are getting adequate nutrients in your diet. This is information to help you in the future where the nutrients coming from. When we talk about iron that comes from animal sources, heme iron is more bioavailable than iron from non-animal sources or non-heme iron. But there are things we can do to increase the bioavailability of that nutrient. Other foods consumed at the same time. If you consume, this is cocktail chatter for now, but if you consume foods that are high in calcium with foods that are high in iron, it may inhibit the absorption of both of them. So bioavailability refers to the amount absorbed and used by the body, and there are a number of factors that can influence the bioavailability of nutrients. The function of vitamins include metabolism. They're involved in helping us get the energy from the carbohydrates, proteins, and fats that we use. They act as cofactors for specific enzymes. Enzymes are proteins that act as catalysts that speed up reactions. I want you to remember that every single reaction in our body involves enzymes, energy, and water. And vitamins and minerals work with those enzymes to help them do their work. And there we go, right there. Protein-based molecules that catalyze chemical reactions. The different categories of vitamins include fat-soluble and water-soluble. You don't need to remember structures. You never need to remember structures. However, I will ask you to remember the difference between fat-soluble and water-soluble. And spoiler alert, fat-soluble are A, D, E, and K. Water-soluble are B vitamins, vitamin C. So whichever one helps you to remember will be what you use. This is a periodic table of elements. If you go into the gray matter in the back of your mind, somewhere you might remember having seen this in a chemistry class. These are our minerals. And because, it's there, I actually have a periodic table of desserts. Don't look at it too closely. It's not that accurate. Some of the functions of minerals include structure, like calcium in your bones and in your teeth. Minerals are also work with proteins, Like iron is involved with hemoglobin to help transport oxygen in the body. Iodine is part of the protein molecule thyroxine that's involved in thyroid function. And minerals also act as cofactors for enzymes during metabolism. Then we have water and the electrolytes. Sodium, potassium, and chloride are minerals, but when they are in a positive or negative state, they are considered electrolytes. They carry an electrical charge. Every reaction in our body moves on electricity: nerve impulse transmission, muscle contraction, heartbeat. Sodium, potassium, chloride, and water are involved in these reactions. The pH scale, you may remember, is a measure of the acidity or alkalinity or base qualities of a food, or, well, anything, I guess. Our pH is really tightly balanced between 7.35 and 7.45. And I'm going to show you a video in a second to make you stop worrying about whether or not that meat you ate or that orange that you didn't eat is going to cause you to get cancer. And here's a fun pH scale, because I could find it. All this information is true. The acid of our stomach is really low. It's just above car battery acid. And pure water is neutral, around 7. Rainwater is a little acidic these days.
Eating an alkaline diet help prevent cancer and other diseases? I'm Tamara Robertson, and you're hooked up to the Feeding.